Hello. Today we will continue our lesson on statistics. Today specifically looking at types of data. We will cover concepts of population and sample, and what a random sample is, and the different types of data, discrete and continuous. So there are two types of data: qualitative data and quantitative data. Qualitative data is data that is not given numerically, but is characterized by description, which is sometimes why it's referred to as categorical data. Examples could be your favorite ice cream or your favorite color. Quantitative data, on the other hand, is data that is numerical or data that can be measured. For example, the number of cars in a car park or the heights of plants. Quantitative data is split up into either discrete or continuous. Discrete quantitative data is data that can be counted or data that only takes on specific values, certain values. For example, the number of siblings in a family, 0, 1, 2, 3, 4, etc. Or shoe sizes, size 3, 3.5, 4, 4.5, for example. Whereas continuous data is data that can be measured, and it can theoretically have any numerical value in a range from a minimum to a maximum, and the value is only limited by the accuracy of the instrument that you're measuring it with. Examples here: heights of plants or the weights of chicken eggs. Further examples of discrete data could be the number of apricots on a tree, again whole numbers, or the number of players in a game of tennis, 2 or 4. And further examples of continuous data could be the time taken to run a 100-meter race, or the distance hit in a baseball game. So in this example, you're asked to decide whether the variable or the data is qualitative or quantitative, and then if it's quantitative, to decide whether it's discrete or continuous. So you can pause the video and try all 6 examples. And here are the answers. The amount of tar in a cigarette, quantitative, continuous. The gender of the students, that's categorical, females or males, so that's qualitative. The weight of a newborn baby, quantitative and continuous, as is the average rainfall, as is the Kevin's mass after he's done his training. And lastly, the number of items bought in a supermarket each week is quantitative but discrete. It's a certain number of items. Again, you can pause the video and try these 3 further examples. The number of heads that you obtain when you toss 3 coins would be quantitative because we can count them, but discrete, either being 0, 1, 2, or all 3 heads. Brand of toothpaste would be qualitative, but it's just different categories, different brands. And the height of a group of 15-year-old children, quantitative and continuous. Again, pause the video while you decide whether the data is discrete or continuous, and give you time to complete the frequency table. So the number of cherries would be an example of discrete data, and the frequency table is shown here. Again, I suggest you pause the video while you decide whether the data is discrete or continuous, and to give you time to complete the grouped frequency table. The length of a telephone call would be continuous data, and the grouped frequency table is shown here. So on to population and sample. The term population refers to the complete collection of all the data being studied or investigated, whereas the term sample refers to a small subset of that population. In the example, if you wanted to find the average height of an adult female in the UK, you could of course measure the height of every female in the UK, although it would be rather impractical. So alternatively, you could take a sample from that population and then use the average height of the sample as an estimate of the population's average height. We would need to ensure that the sample is well chosen to provide a reasonable, reliable, and representative estimate. In this example, we're told that 492 employees from a single company participated in the study, and those who were on flexible hours showed a 5.3% increase in productivity. This suggests that all workers in the UK should have access to flexible hours. That's the report statement. In this example, you have to identify the sample, the population, and decide whether you think it's a reasonable generalization. So the sample is the employees from the company who participated, and the population is all the workers in the UK. And since there's no indication that the sample of employees from this company is a good representation of the population of all the workers in the UK, is not a reasonable generalization. So, a random sample. This is a sample of the population selected completely at random, as it says. We can do that in a variety of ways. We can pick numbers from a hat, or we can generate numbers using a random number generator. So with a random sample, each item in the population is assigned a number from 1 to n, where n is the population size, and then a random number generator can be used to select the number of items that we want from that sample. So in this example, it's been decided to interview 20 students from the high school out of 659 students to survey their views. So we assign every student a number from 1 to 659 and then use a random generator to choose 20 random numbers. And we can do this on your graphical calculator. So follow the instructions here. On your graphical calculator, go to Run Matrix, menu 1, and press the Option button, and then F6 to tab to the right, and then F3 to get the probability tab, followed by F4 to get the random numbers tab, then F2 because we want a random integer, a random whole number. And then the three parameters we need to input are, we need to tell it to generate one number at a time. So we start by inputting 1, followed by a comma, and then we put the population size, in this case 659, followed by a comma, and then the sample size, 20. Close the brackets, press execute, okay, and we will get a list of 20 random numbers generated between 1 and 659.